In this video, we are going to find integers x and y such that x cubed minus y cubed equals 2xy plus 8. Before we move on, don't forget to give a like, subscribe to our channel, and turn on post notifications. This equation can be solved with an interesting trick, which is by letting a equals x minus y and b equals xy. Then we can actually express all parts of this equation in terms of a and b. Indeed, if we try to cube x minus y, so part of it will be the difference of cubes, and then the extra parts that's generated is actually 3xy times x minus y. And so we can quickly write the difference of cubes as a cubed plus 3ab. And so our equation now becomes relatively easier, which is that this expression, a cubed plus 3ab, equals 2b plus 8, and we can easily make one of the variables the subject of this equation, which is that a cubed minus 8 equals b times 2 minus 3a, and so we have b as the subject. That is a cubed minus 8 over 2 minus 3a. Now, since we have to solve for integers for x and y, that means a and b also has to be integers. And we have b equals to a fraction of a, so it remains to find out what values can a take so that this fraction is an integer. Or in other words, 2 minus 3a divides a cubed minus 8. And to make things easier, instead I'll consider this relation, which is 3a minus 2 dividing a cubed minus 8. And I'm going to use mod, which is that by looking at mod 3a minus 2. Now by definition, we have a cubed is congruent to 8 mod 3a minus 2. But on the other hand, we can also say 3a itself is congruent to 2 mod 3a minus 2. But that is clear because if 3a is subtracted by 2, then it's exactly equal to 3a minus 2, or I can put it as a multiple of the expression. Now, these two congruence equations have some similarities, which is that for the left side, it only contains one term with a, about a, while for the right, it's a constant. So we can try to find some kind of common ground between a cubed and 3a, and indeed we can do that by multiplying a cubed by 27. So 27a cubed is congruent to 216 mod 3a minus 2. And on the other hand, for 3a, we can cube both sides. So we also have 27a cubed, but this time we have 8 on the other side. Now from this we can tell that 216 and 8 should actually be congruent mod 3a minus 2. Then we know that 208 has to be congruent to 0 mod 3a minus 2, simply subtracting both sides by 8. And now we know 3a minus 2 has to be a factor of a constant 208. So there are only finitely many possibilities for the value of a. Here are the factors of 208. For each factor of 208, we can solve for a value of a, but not all of them would give integers. Here are the integer possible values for a, and there are 10 of them. For each possible value, we can find out the corresponding value of b, because we have found out that b is equal to this fraction, the yellow fraction, a cubed minus 8 over 2 minus 3a, but that would take a lot of time. So to further reduce the number of possibilities, I'm going to consider this expression, which is a squared plus 4b. The reason that I do this is that, to recall, we are not actually trying to solve for a and b only, but to solve for x and y. Recalling that a equals x minus y, so this expression equals x minus y all squared plus 4xy. And in fact, that is exactly x plus y all squared. All is left is to see which values of a would make a squared plus 4b a perfect squared. A perfect squared means it's not just an integer, but it also has to be positive and a perfect squared. So another thing that makes a squared plus 4b easy to find is that I can now express b in terms of a. So I can skip the process of finding the value of b. Now, a squared plus 4b is a squared plus 4 times a cubed minus 8 over 2 minus 3a. And simplifying, this expression equals a cubed plus 2a squared minus 32 over 2 minus 3a. And if we put each value of a into this fraction, we have the following values. Notice that most of them are negative, except one of them, which is 4, and it's exactly perfect squared. For a squared plus 4b equals 4, that happens when a equals 2 or minus 2, and b equals 0. And that means x minus y is either 2 or minus 2, and xy equals 0. So that means either one of x or y must be 0, and the other would be 2 or minus 2. So at this point, we have these solutions. And we can check by putting that into the original equation. For x cubed minus y cubed is either 8 or minus 8. Let me put that down. But for 2xy plus 8, it must be equal to 8. So we can reject the cases that gives x cubed minus y cubed equals minus 8. And that would be minus 2, 0, and 0, 2. So our final answer would be 2, 0, and 0, minus 2. Please feel free to share ideas in the comments. Thank you for watching. See you next time.